Good afternoon all. This is the configuration of dual input balanced output. So differential amplifier is divided into four configurations, that is dual input balanced output, dual input unbalanced output, single input balanced output, single input unbalanced output. So these are the four configurations differential amplifier is divided. So we have to analyze AC analysis and whereas DC analysis for these four configurations. So first basic configuration is dual input balanced output, that is DIBO. So now we have to derive the DC analysis and AC analysis for DIBO. So first one is DC analysis. We have to derive DC analysis first. So this is the block diagram for DC analysis differential amplifier, and you all know we are taking two transistors Q1 and Q2 transistors. So this is the base B1, this is the base B2. So this is the base B2. This is collector and this is collector, this is emitter and this is emitter. So these are the two transistors and these two are DC supplies, that is VCC and minus VEE. Emitter voltage or VCC plus VCC minus VEE or minus VCC, anything we have to take. So these two are the collector resistors, and whereas current flow these two resistors are RC1 IC1 current, RC2 IC2 current, and this is the emitter resistor. So in emitter resistors two current will flow. One current is from emitter 1 Q1 transistor current and one current is from emitter to Q2 transistors. So in this resistor we have the sum of these two emitters current. So for that purpose I am taking 2IE. 2IE means emitter current with respect to of two transistors, two emitter transistors. So now we have to design the DC analysis. So for DC analysis, now I want to apply the KVL for base to emitter loop of Q1 transistors. Now apply KVL for Q1 transistor base to emitter loop, base to emitter loop, right? So in DC analysis what we have to find is, we have to find two operating points. Those two operating points are, first operating point is ICQ, emitter current at Q point, ICQ. And next one what we have to find is VCEQ, Q point. So emitter to collector voltage, collector current. These two operating points we have to find. Okay, these two operating points we have to find. So now apply the KVL for Q1 transistor at base to emitter loop of Q1 transistors. So what was the KVL here? So this is minus IB RS minus VBE minus 2IE RE plus VEE is equals to 0. Applied here. This is the loop 1. Applied KVL here. So we all know IC is approximately equals to IE. Means IE is equals to IB plus IC. If collector current is 100%, then base current is 5%, collector current is 95%. So IE is approximately equals to IC, right? But the formula for collector current IC is equals to beta into IB. This beta means H parameter. Beta is also known as HFE also. This is the basic formula. IC is equals to beta into IB. Whereas IC is approximately equals to IE. then we can write this IB is equals to IE by beta, whereas this IE is equals to IC. IE is equals to IC. So IC beta is equals to IC by IB, but we are writing here IE. So IB is equals to IE by beta. So this is the first equation. So now substitute in equation 1, substitute in equation 1 IB substitute చేయటం. IB substitute చేస్తే we get so IB means IE by beta, so minus IE by beta into RS minus VBE minus 2 IE RE plus VEE is equals to 0. Plus VEE is equals to 0. By substituting, we get this equation. So here we have two IEs. Here IE and here IE. So I am taking IE as common. So IE is equals to minus RS by beta minus 2 RE plus VEE minus VBE is equals to 0. I just substituted this IB equation in equation 1 and then I taken IE as common. Okay, sorry, here this is not into, this is not equals to, this is into. IE into minus RS by beta. So therefore IE is equals to VEE minus VBE by RS by beta plus 2RE. Okay, here I am neglecting this value because by comparing this beta, this RS is small value. If we take the source resistance value is very low. If we assume this RS value is 100 ohms, then this beta value is very large. So small value by large value. For that purpose, I am neglecting RS by beta. Neglect RS by beta. Then IE is equals to VEE minus VBE divided by 2RE. Whereas here IE is approximately IC. We get here IE value. So in this we have to find IC operating point. So we can write ICQ is equals to VEE minus VBE by 2RE. Okay, this is the ICQ value. And next we have to find out VCE value. So we have to find VCE value. So for VCE value, we have to write the output voltage of this transistor. We are taking output at collector. So what was the to find VCEQ? To find output voltage at the collector, VC or V not anything, VC is equals to, then what was the output for on transistor? VCC minus ICRC. Then to collector to emitter voltage, we can write as VCE. So this can be written as VC minus VE. So substituting in this, VCE is equals to, VC means this value, VCC minus ICRC minus of, what was VE here? VE ante enti ikkada? VE is nothing but VBE ఇక్కడ VE తీసుకుంటున్నాం మనము ఎమిటర్ వోల్టేజ్. ఈ ఎమిటర్ వోల్టేజ్ ఏంటి, ఇక్కడ బేస్ నుంచి వచ్చిన వోల్టేజే. బేస్ నుంచి వచ్చిన వోల్టేజ్నే VE ఈజ్ నథింగ్ బట్ VBE. VB minus VE is known as VBE. So this VE can be written as VBE minus of minus VBE, minus of minus VBE. ఎందుకు మైనస్ తీసుకుంటున్నాము అంటే దిస్ ఈజ్ ప్లస్, దిస్ ఈజ్ మైనస్. ఇలా తీసుకుంటే మనము VBE తీసుకుంటే దిస్ ఈజ్ ప్లస్, దిస్ ఈజ్ మైనస్, అందుకనే మైనస్ VBE. సో VCE ఈజ్ ఈక్వల్స్ టు VCC ప్లస్ VBE minus ICRC. This is about VCEQ. VCC plus VBE minus ICRC. This is the operating point of VCEQ. This is the operating point of ICQ. So this is the dual input balanced output DC analysis. In DC analysis we have two operating points, ICQ and VCEQ. So we find here ICQ value and VCEQ value. Thank you.